Algebra 1 students, welcome to your notes on quadratic graphs and their properties. The big idea, a quadratic is a function that can be written in the standard form y equals ax squared plus bx plus c. You guys probably will start to notice that this looks incredibly similar to our previous unit when we wrote something in standard form. And in our previous unit, we just had this piece of it. And now we've got the y equals. So in our previous unit, this was still standard form over here. But now we've got this whole y equals piece that we're adding here. And that's going to affect a lot of stuff that we're going to do when we're graphing quadratics and some other things that we're going to do in this unit as well. So let's take a look at the parent function y is equal to x squared, and something that you guys probably remember from our linear equations unit is it drives me crazy to see a graph, and when it has lines in it, it doesn't have the arrows on the ends of those lines. These arrows in this particular case are going to be incredibly important. We're going to talk about those more in this set of notes as well. So a couple of pieces of vocabulary that are important on this page. You are going to get a parabola, and kind of like we do in class, I want you to say parabola out loud right now. Go say parabola. And when you are graphing a parabola in standard form, if a is greater than 0, then the parabola is going to open upwards, and the vertex is going to be a minimum. Okay, so if a is greater than 0, like it is in this case, your vertex, which is sitting right here, that's the tip of your parabola, is going to be a minimum. All right, so your vocabulary on this page that you need to know is parabola, minimum. I don't know why that's there. Go away. Your vocabulary on this word, or on this next one, is going to be parabola and maximum. Okay, because if a is less than 0, then the parabola opens downward and the vertex is a maximum. We've also got some other vocabulary on this page as well. We've got the axis of symmetry. The axis of symmetry is this dashed line right here. All right? And that dashed line that I kind of created there and then erased, that dashed line is invisible, but in this unit we're going to actually sketch that quite a bit. Okay? We also have a vertex. The vertex is the tip of the parabola, and if I zoom in, you guys hopefully can notice that my parabola is a curve shape. It has a curve to it. It is not a totally straight line as it is in our unit on linear functions. Okay, this is not linear. So it does not come to a V like I have displayed next to that graph. It doesn't do this right here, okay? So this is incorrect. Don't do that. Okay, so our instructions for number 1 and number 2 are to identify the vertex and tell if it is a maximum or a minimum. Again, I don't like it if I see a parabola and the oven's ready to go. I don't like it if I see a parabola and it doesn't have these arrows on the ends of it. It drives me absolutely bonkers. I will take off points if you don't have these arrows on the ends of your parabolas. Okay? So to identify the vertex, again, the vertex is that tip of the parabola where it comes to a curved ending, if you will, or I don't want to call it a point because then you guys think that the parabola has linear equations leaving from it. It doesn't. They're a curve. So the tip of my parabola is called the vertex. Okay, and I want to think about whether or not it's a maximum or a minimum. I want to think about my y values. So as x is approaching my vertex and it comes to a minimum right there, and then it starts to go back upwards, okay, as x goes from left to right, kind of like you're reading a book, I come to a minimum y value right down here where my parabola is. And so I have a vertex at 1, 2. So my vertex is at 1, 2. And I have a minimum if I can spell, at that vertex. Okay? So for number 2, I've got to put my arrows there on the ends of my parabola, indicating that I understand that it goes off that direction, keeps going. I've got a vertex right here. It's got an x value of -1 and a y value of 1, 2, 3, 4. So my vertex is at -1, 4, and that in this particular case is a maximum. Okay, so students, on number 3, what I want you to do is I'm going to have you pause your video. I want you to create, when you pause your video, one of these 4-column charts. All right? And when you do that, I want you to go from -2 to +2. All right? And you guys in my class have gotten really good at doing these. Oops, this should be a Y. And we'll talk about that when you get back and how to graph that. All right, let's change up our normal scale here. Let's count by let's count every other x value here. So let's go 1 there, 2 there, 3 there, and then -1, -2, -3 would be over there for our x values. And on our scale for our y axis, let's count by 2s. So let's go 2, 4, 6, 8, 10, 12. And it looks like this graph is going to be going upwards, so I don't need to make my values on the negative y-axis. So our first point is -2, 12. So -2, 12 would be right there. Okay. Our second point is -1, 3. So -1 and 3 would be halfway between 2 and 4. We've got 0, 0, or the origin. And then we've got 1, 3. And then we've got 2, 12. So those are my points that I'm going to plot on my parabola. I'm going to zoom in just a little bit so it's easier for me to draw my curve. Remember, I don't want this to be a straight line. This has a curve to it. It is an exponential curve. Okay? We're trying to flatten that curve of the coronavirus right now. So we need to have a curve on my graph when I create my graph. Notice that my graph does not come down and go into the negative area of the y-axis. So we have a minimum here at the origin, at the vertex of my parabola. Let's talk about domain and range, okay? So your domain are all possible x values. Your range are all of your possible y values. So we need to talk about the ends behavior as we need to talk a little bit more about these arrows that I've been having you draw on the ends of your graph. Okay, these arrows up here. The end behavior as this graph of my parabola goes off this direction towards positive infinity for y, or as x goes towards negative infinity. Okay, if I was to continue to go this direction on my table, I could actually keep going that direction all the way off to infinity. And as x approaches negative infinity, as x approaches negative infinity going off that direction, y continues to get bigger and bigger this direction. So my parabola is going to continue to go up that direction. All right. Conversely, as x approaches positive infinity, as x gets really, really big and goes really, really far in that direction, if I was to continue to zoom in and go that direction, y continues to get really, really big in that direction, or my y values continue to head off towards positive infinity. So what we say about that, we would say that our domain is going to be equal to all real numbers, because it's going to continue, it's going to contain everything across the entire number line on the x-axis. It continues off to negative infinity, it continues off to positive infinity. So we use this funny looking R with a line in it, indicating that we are going to have all real numbers in our domain. Our range now, we've got our range. That has all of our possible y values. So that one we are going to write as an inequality. Our inequality is going to include 0, because you'll notice that our parabola has a vertex at 0, so it can include the point of 0. So as our graph comes down here, it gets really, really close to 0. It actually touches 0, but it doesn't go past it. Okay? And I could zoom in or get really close to that. I can get infinitesimally close to 0. I can include 0, but I cannot go past it. Okay? So, y can be greater than or equal to 0. I cannot go lower than 0. And if I wanted to write this the other direction, I could write that like this. Y is greater than or equal to 0. I could say it either direction. Both of them are fine. Both of them are, in fact, correct. All right, so Algebra 1 students, what I want you to do on this one is I want you to pause your video and create your 4-column chart so that you can graph this function. Okay, so you can see my 4-column table that I created, and you can see I've already plotted my points on my graph. In this particular case, A was equal to -1/2, so that means my parabola is going to open up downward. And we talked about that on the first page of the notes, and so this is a little bit of discovery of that for you. So I also want to really point out and really overemphasize the fact that these are curves. And so again, we're going to talk about the fact that we're going to talk about the domain and the range. And the domain, again, is all of the potential x values. And so some of you are going to get pretty used to in this unit that it pretty much is always going to be all real numbers. Because as the end behavior of this graph goes off to negative infinity, and as the end behavior of this graph goes off to positive infinity, it includes all of the values of the entire number line for x. So for range, it's all of the potential y values. And in this case, we have a maximum at 0, 0. We have a maximum right there at the vertex of our parabola. And so 0 is going to be greater than or equal to y, or y is going to be less than or equal to 0. We can write it either direction. And what that means is as x approaches negative infinity, as x goes this direction, y continues to go off in this direction towards negative infinity. And as x, and in behavior, goes off and gets really, really big and goes towards positive infinity, y goes this direction and gets really, really little and goes off towards negative infinity. So that in behavior is important to consider.